Hello, I'm Richard Slavanko, and today I'm hopefully going to help further your understanding and perhaps provide some direction dealing with comparison studies and the claims that may or may not be involved with them. And in the case of comparisons and claim type investigations, oftentimes there are not standards to cover the processes that will be needed for the investigation. The seminar will be looking at those considerations and techniques to deal with this type of a situation. So hopefully you find the following materials of use. And at the conclusion of the presentation, I've gone and taken the liberty of creating some questions based on experience here at 360 Test Labs and 360 Product Testing that we get in one form or another frequently. So let's dive in. The learning objectives for this webinar are as follows. One is to understand what's a medical claim and what's not a medical claim. We're not going to be focusing on medical claims. That's a very specialized consideration. The next thing that we would like to do is help you learn about as an objective is the different types of claims and comparisons, because there are differences. They're kind of in different categories, and understanding exactly what category they fall will help you conduct the testing more robustly and efficiently. Then we'll talk about standardized testing versus scientific testing based on a representative type use case, and understanding how those differ and how to approach them should be useful to the practitioner. We'll also talk about the strategies for testing. They include the breadth, how comprehensive are we going to test, and what's the scale? I mean, thousands of samples, tens of samples, a sample. And the final learning objective is the developed data from the contracted protocol sometimes is supportive. It's always nice. Sometimes it's something else. We'll talk about that. So if everybody's ready, let's dig in a little bit here. And let's talk about that first learning objective, medical and health claims versus a regular claim. Taken from the FDA, you see on the slide here, is that the quote shows that if it's intended to affect the body structure in any way, whatever it is, this product or device or lotion, whatever it may be, if it's meant to change or alter the body, it's likely a medical claim. And if you're not a clinic dealt with these kind of things, then this is not something you should really be endeavoring to wade into. Non-medical claims, as seen in this next slide, there are, as shown here, basically 4 different types of claims, 2 of which are based on comparative work. So the first one is a category. So I show here in the slide some examples of what a category claim will be, such as safe for all septic systems, works on all brands of what you name it. And those type of claims, it's not comparing to anything, you're just talking about compatibility. It's different than a comparison. And more specific about comparisons, there's a non-comparative claim. And when we say, for example, as written on the slide, removes old wallpaper or buildup or paint, whatever, that would be not comparative. You're just making a performance claim of sorts. Or you're saying that it is good for 90 days. It's a claim of durability. It's not a comparative claim. You're not, unless you may say, your customer may say to you, I want to show that mine's more durable than the other person. and or may say that mine's as durable as the other product, then you're starting to get into the next subject, which is comparative, and that's parity. So, for example, cleaners is a good category to talk about comparisons because it's very popular for such. There may be these organic formulations, vinegar and lemon oil, let's just say, that want to show their equivalent in cleaning power or similar in cleaning power to something more robust, industrial grade like Fantastic or Zep or some other beefy type cleaner that a consumer may not want to use in their house, or others may have the reason for not having, but they need good efficacy. So they maybe want to show that this product is similar to that product, and that would be the parity claim. Then, of course, the obvious one, which is my product's better than the other guy. I mean, so good. I mean, it's just so good. And therefore, it is where we're trying to establish there's a superiority in its performance or its attribute, dries faster, lasts longer, uh, smells better, whatever the case may be. So those are the categories of claims that we're going to speak to broadly today. And let's now dive a little bit deeper into these categories. And I'm showing an example on this next slide here about a category claim. In this case, they're talking about the compatibility with different types of materials, how this stuff, I don't want to be too technical, stuff, when you spray it on it, it works on these things. And how that's determined and so forth and how that's established is our job as lab professionals, which we'll get into more of the substance as we go on. But that's just an example of the category claim. Moving on to the next one, non-comparative. This is an example from a Ritz cracker where we're showing there's a green dashed circle that almost looks like the artwork, but it says whole wheat. I mean, establishing that it's whole wheat is not a comparison. That it has 5 grams of whole grain, that's a finding of fact. That's not a comparison. So this circle dairy is saying, yes, baked with whole wheat and 5 grams of whole grain would not be a comparative claim, but it is a claim if it's saying it's in there, and it may or may not be, and that may be the lab's job to prove. The next slide is talking about parity. So this particular example, I believe, is from a product at Walmart, where they're big on compared to, which is a popular language that is used for these types of equivalence or parity that are claimed. And you can see that they're showing that there's a national brand, unnamed, that we're supposed to think of. They are very similar to that. There's parity. So why pay more may be their value proposition when you can buy this one, which is similar. It's on par. The next slide is talking about, well, I don't want to say it's just as good as, it's better. It's a lot better. Oh my God, it's good. It's superior. So in this case, we're talking about some, I believe, an HVAC item, and they note that 33% more air velocity than leading competitors. Now, it's very common that the actual competitor is not called out, and there's lots of reasons for that. Some of it happens to be that the product's always changing, because if you call out a competitor, they may change it. So now what are you going to do? Change your claim? Or are you going to test again, et cetera? These are considerations. However, one can establish whether it has 33 more air velocity than a host of leading competitors. And it may or may not have that. The lab established whether that is or is not the case. So going on now in this next slide, we're talking about that whatever the claim may be or whatever the comparison may be, we need objective substantiation. That's why they came to us, because if they want partial, oh yeah, my uncle said it is, or yeah, we tested ourselves, it is. Well, if that was always good, there wouldn't be other labs around. And there are other labs around, because the fact is that because you said so and it's your product doesn't mean I believe it, or doesn't believe that, and it isn't sufficient proof for a lot of cases. So let's deal with how do we get this objective substantiation. So I have reproduced one of my favorite quotes, and we have a few of them around here, but this one's always good. From Edward Deming, obviously a name that many will recognize, and for good reason. But it really says a lot. I'll read it out loud because it's just fun. In God we trust. All others bring data. That's good stuff. So you said it is, that's fine, but if I'm the buyer at Costco, how do I really know it's as good as Cascade, or it's really as durable as, you know, the gloves that we sell for, you know, cleaning purposes of, you know, the dishwashing type gloves? Well, let's just test to the standard. Let's just get the standard for testing that particular item. We execute the protocol. We come up with the data. You know, it is or it isn't, which is great when it applies. So as noted at the bottom, they're very specific. Anybody that's in this industry for any amount of time knows that standards are, if nothing else, quite specific. And there's a lot of business needs that are equally specific. And there are no standards that cover them in any kind of substance. But let's just talk about standards in general. So there's lots and lots and lots of organizations that publish standards. And these are all names a lab will recognize. And each one may have hundreds, if not thousands, of standards and sub-processes within those standards. It's a lot of published procedures. And you'd say, well, geez, that must cover a lot of stuff. And it does. Fortunately, Contract Laboratory webinar series, just now available, is set up to go through a lot of the practicalities and uses of these published standards, of which I've shown you many examples. So if you would like to learn more about published standards from a professional point of view, and it is encouraged from at least my perspective, the way to do that is go to the contractlaboratory.com's website, and if you go to their events page, you'll see some of the available now standards webinars, and they will be added over time. Once again, that's contractlaboratory.com at the events, and that's their standards-based testing webinar series, which will provide a lot of useful information for the testing professionals out there. But getting back to the subject matter of today, as this next slide talks about, and the slide says a lot, what standards are appropriate for comparisons or claims? And all too often, the answer is in entirety none. Their specificity is so extreme that they're not broadly applicable. So we'll talk a little bit more about maybe we can use parts of them, but for the standard itself, you can't just say, okay, we're following ASTM, whatever it may be, and we're going to come to your business need of equal in performance parity, or if you're superior, or if it does really work on all these just broad compatibility with all these different things, or if it does have 5 grams of grain in it, etc. When we look at standards, one of the reasons why it really doesn't cover a lot of our needs for these comparisons or claims is, for example, when we're trying to show something superior, showing that everything's compliant with the standard just says everyone's equal. It's a parity claim. Oh, we all are compliant with XYZ standard. Well, that doesn't say what I want to say. I want to say mine is superior in performance for X, or this has a capability none of the others have. For example, it may be able to do a function that others can't do, and I need to show as a laboratory that it does have that function, others don't. Well, finding a standard to do that is not likely going to be a very fruitful search. So that's kind of why this webinar that you're watching here today exists is, well, now that you're in that circumstance, or you're considering that circumstance, or you've been asked about that circumstance, what do you do? There's things, for example, that they want to put on the package, and it's not something that there is a standard readily available for, but they want to use part as their basic marketing and labeling of their product. And now we've gotten so specific, and standards by themselves are so specific, there's just very little chance they're going to align to where you can test against one. And so we'll actually cover a case history, an example. And as you see here, first I want to say is that we're not belying the confidence of a customer. This product has been discontinued when Purina bought the company. So this is not something where the confidential nature of all our work is being compromised. We take that very seriously, as I'm sure you do at your labs as well, and I'm sure our customers expect of us. So anything that we will discuss in specific today has cleared the barrier of making sure that there's nothing here that is in any way proprietary or in confidence. So in this particular product, there's a blue box. That's not the artwork. And that's focusing on what we want to talk about. And it's a little hard to read there. So in this next slide, we actually have that reproduced. And then we're going to talk by element because it'll be illustrative. So this is what's in that blue box in actual writing that older eyes can see. So one of the things they claim is that they have a liquid absorption capacity at least 3 times greater per ounce than the leading clay-based litter. Well, they're basically saying, I need a standard, if we're going to go by standardized tests, I need a standard that's for clay litters that talks about their absorption. And that we also need a standard that talks about ammonia odors. And this is for clumping litters. And then lastly, we would need the standard for, I want to show that it's harder clumps. The clumps take a greater force to break, or however we define harder, than pine, corn, and wheat clumping litters. I think this illustrates well how very specific a claim can be, and how even if there's a standard out there that may address some of it, it's real specific. So looking at the next slide, let's talk a little bit about standards coverage. So the first one, the absorption capacity that I just read to you, and I've grabbed 3 ASTM procedures of some broadness. There's others out there, but it's not for plastics. It's not for sandwich construction of stuff, for core materials. It's not for the rate of absorption of water by hydraulic cement concretes. You're welcome to find other ASTM procedures, but they're not litter ones that I think you're going to find. However, there may be procedures in there that we can use, and we'll speak to that a little bit in the question and answer elements that follow the presentation. You can see the ASTM D570 2022 is talking about pre-drying. Pre-drying for litters is a problem because, as the next bullet speaks to, can they be dried equivalently, and does it affect them equivalently? And from experience, the answer is no. It does, as the next point speaks to, heating or drying does change the properties. So some basic procedures that is widely followed with standardized absorption preparation is problematic here. And you saw we were talking about a lot of different types of materials, and in this case, they're problematic for the purposes of comparison and the claim. Now, there may be procedures and instruments that can establish what absorption is done using a particular machine, but that machine was likely built to obey a certain protocol, which I doubt is anticipating litter. And the next one that we'll speak to is harder clumps. I pulled 3 ASTM procedures: Rockwell hardness, a very common one, rubber properties, and Rockwell hardness of plastics that are used for insulating. Doesn't sound a lot like litter to me. Probably doesn't to you either. In these standardized procedures, they're anticipating some kind of a coupon or some kind of uniform test sample, and that's problematic for the usage of litters and the way clumps form per se. And furthermore, it's a two-step process, because you're not really looking for is a clump hard. You're looking for a clump used as litter being harder than another clump used as litter, and the comparative differences. Again, we're getting very far afield of the hardness that standards that are generic or available will anticipate. So as the next bullet talks about, the clump size, shape, and the characteristics are going to vary widely, and the test protocol has to anticipate that. As with most things that are non-standardized in testing, which I'm sure anybody that's been around a little bit, it requires a lot of thought, because when you get down into the detail, everything's complicated. It's, devil's in the details, and everything's complicated. And there's a reason standards exist, but you can't rely on them for everything. And this is just an area where you can't rely on them. So going into another kind of discipline that's not on package, may be used in broadcast. For example, novel claims that are used at QVC. Well, QVC claims are so specific. They will make the product seller verify every single thing that they say, specifically tested on exactly what they say. So they don't even want to hear about a standard. They want to say, if you say it cleans X, you better show data where it cleans X and results in Y, just like your claim said. Very novel, very specific. And I use the cleaning example because it's on the slide here. In this case, the claim was cleans, shines, and repels dust and dirt for 3 weeks and more. Very specific and complex. It's interconnected with a whole bunch of things. Now, the next one below that is that it says, and this is from a QA form for QVC that I've borrowed the example, and removes grease quickly and easily. How do you define easily? That's something that is going to be a challenge right in and of itself. What is easily? Whenever you don't have a standards, how do you define that objectively? And then how do you demonstrate that robustly? This is the job. This is the challenge. How do we demonstrate that such that QVC accepts it, or your client doesn't get involved in a nasty lawsuit because of some product they just shipped 100,000 to Walmart or Albertson Grocery, who knows what, just stuff the distribution channels. How do I construct this testing is to look at how it gets litigated. We here at 360 end up supporting a lot of litigation. We end up supporting a lot of things that might be litigated in the future based on an aggressive client, making some aggressive claims based on data that we've generated, etc. And one of the things that you'll find or may find if you do a little digging is that when lawyers talk amongst themselves in various venues, they'll notice or speak to that there's a tendency when the dispute is in, for example, the Better Business Bureau's National Advertising Division dispute, they'll choose the data that's based on a representative use case that's typical, meaning if I have two sets of data, the guy making the claim, the guy that's got the claim against him, and the guy who's got the claim says, no, that's not it. And he says, yes, that is. When these guys are fighting and they end up with, surprisingly, shockingly, two sets of data. The NAD has a tendency, as the lawyers seem to think about it, that they'll choose the data that's robust and scientific, that's closest to the use case, meaning when they tested it through the independent providers such as your lab or our labs, did they test against a scenario like the end user does? If they tested some obscure scenario, then was it orchestrated just to make them look good? Because it might be. The NAD, for example, may say, we're looking for how it may get used in the home or the workplace or wherever, because that's what the claim pertains to, how the end user uses it. It should be independent, scientific, robust, and reflect typical or common uses of the product. If you keep that in mind, that'll serve you well. We would like to create for the customer really robust, thoroughly vetted, researched data, robust data. And as this next slide shows, that also has a price, which is possibly very high because you're doing one-off testing, you're creating protocols, you're vetting the protocols, you're setting up for those protocols, and then you're creating deliverables based on these all unique proprietary one-off things, or maybe they're not unique, or it's just something that has been developed that is not such as just doing compliance testing one after the other of a particular type of product or service. And that's a formula for cost. This is knowledge at a cost that's not cheap if we have high predictability, high confidence, high certainty. And, even the biggest customers of ours, and some of them are as big as they come, and they don't have infinite budgets either. I kind of think of it as like, if Coke was going to make a claim about taste or something, do they sample everybody that drinks colas? It's going to be very expensive. As this next slide speaks to, there's a continuum or a balance between budget and scientific certainty. So the lawyers always say, yeah, more testing, more. Lawyers spend money, the client's money. So they want more, it's all better. No reason to hold back, do it all. And the customer or the client saying, there's got to be a place where we can get what we need and are willing to pay for it. We don't have to go crazy. I understand lawyers will tell you, the dentist says you have to come back every 6 months. Your pediatrician or your doctor says you have to come back every 6 months. Everybody's got their Their plan for what's the best way. And lawyers will be conservative. Not every customer, most customers are not as conservative as lawyers would prefer. So there's a balance that the lab works with these folks to find the right answer that serves the purpose, that everyone can find some agreement on. There's a zone of agreement somewhere in there if it's done right. So as we look now at the strategies for testing, you can see the three bullets there. It's kind of what are going to have to be figured out, and they're going to come up with what is going to be the cost, which is the protocols. How elaborate are we getting, with protocols? Are we investigating each nuance of the claim, or do we just need to establish the top line part of it or the comparison? Do we do it for, some people say the best of something. Do I test every one of them? Because that's the best. What certainty do you have if you haven't tested all of them and you say the best? And, if I test them all, do I test one of each or do I test 1,000 of each? The scale. All of these things factor in the reliability of the data, the cost of the data, the schedule of the testing, and on it goes. So let's break them down a little bit one by one. Now, looking at protocols per se, as far as our strategies for testing, best practices may or may not be standards-based from an organization that may be a trade group, maybe a publisher of standardized testing, etc. The key is that we want to, as best we can, bring robust investigative processes to whatever we're investigating, and those protocols need to anticipate significant scrutiny. As mentioned, oftentimes comparisons and claims end up in dispute, legal question, whatever form it may be. And it is incumbent upon the lab to do its job in providing a professional work product that anticipates a hostile viewer, an unsophisticated viewer, and many other types of viewers. And in the case of a sophisticated viewer, who can maybe not agree with, but understand and see why a particular protocol and process was followed in the greater sense of science. We have a protocol that is robust, best practices for the elements that we can select that have some procedure that we are comfortable with, know of, or have investigated. And that's going to be how we're going to test it. But the question is, well, then now, as we spoke a little bit about before, is the breadth, and how much breadth is going to be involved. So in the case of creating something robust, kind of touched on a few times already, it should be broad enough that it's not just one single use case, because if it's really superior in one use case and it's just horrific in the other, that's going to be problematic. It should, the customer should be able to know when the testing is done how they fare overall based on a few sample points, use cases. So for example, we've been talking a little about cleaning. Does it clean all these different surfaces, or is it just really good with greasy type materials on alloys? it would matter when somebody's making a claim. However, to be fair, counsel, this is the customer's counsel, may say, that's all we want to test because our claim is going to be it cleans grease better on metal, which is fine. You don't need to test every type of metal, maybe a couple. They may want to go with just one. That's the lawyers and the counsel's prerogative. But we're here to advise best we can. And the scale, we spoke of it a little bit. I want to speak a little bit more specifically now. One of the things that is at least a place to start in regards to how big the sample would be is to look at the ANSI ASQ Z1.4 table. And it's an inspection protocol or sampling method. But when you think about it, when you're doing these comparison type tests, you're often taking a mass produced item and you're then evaluating or creating data for specific metrics about this mass produced item. So it is, in effect, we can think about that somebody's produced a bunch of this stuff, typically, and there's many lots of it. And we're picking a sample. Maybe we bought it from Walmart. Maybe it came from Amazon. But the point is that it's typical of picking out of a lot samples. And then we're going to then see how they perform. So when in typical sampling, you'd be talking about rejection criteria. We can still look at the sampling for the sakes of what is reasonable from the inspection we're really doing. We're taking a mass-produced item of which we're pulling randomly lots. And then we can look at, does it represent a reasonable amount of certainty in procedures like normal inspection procedures or specialized inspection procedures or whatever. And there's people listening right now that are much more familiar with this than I. We have PEs that do this more than I do. But the point of it is that it can guide the scale that's going to be used and create a rationale that's justifiable. Without getting very specific, we recently did something where the test points were created for a shape of something. And there's formulas and there's various literature about how many points you need to determine to have a certain level of certainty with the shape. And those become your test points. So what I'm trying to kind of communicate is that we're taking established science, established testing methodology, and just putting it into a different framework, but it's still rational to come up with the level of something in regards to scale. And we looked at it almost in the same way when we're looking at protocol. Where can we find these elements that will give us the comfort and confidence that our data is predictive and reliable and reproducible such that the client can use it for the business purposes that they have intended, comparative or for claims. If we're looking at the perfect world, which none of us live in, we do tons of samples of different types of competitive products, the variants, and then we would do 10, 20, 30 of each of those, the replicates. So that would be, as we talked about, extreme cost, extreme effort, and likely over the top for what is needed. And if we go back to what we were just talking about with using some of these underlying, long-standing protocols for sampling and so forth, we can come to a level of scale and breadth with the variants and the replicants of those variants that the customer may find acceptable in cost and hold up well to challenge. So when we go in and we come up with all these protocols, this is how it's going to get tested, this is the breadth of which we test, these are all the variants, and this is the scale of which we're taking, all the replicants, and we do the test. And it's, thank God for the client, it's real supportive, or it's close to being supportive, or it's showing that it might be supportive if we did some more tests, or maybe we changed some of the things about what's being tested. There's one thing great about our industry, which I'm probably not telling you anything, is that testing leads to more testing. Once you test something, get data, you're like, I wonder what happens then if, which is more testing. So that kind of falls into the something else class. It's not what happens, for example, here oftentimes is it's not exactly what you're looking for. It may be close enough with a slightly different claim and with some careful wording about, based on X, Y, or Z. But sometimes it shows something completely different. It's not what they were hoping for. But sometimes, too, it shows another attribute of which they may be superior or comparable or a very high import. A quick example of that, which is kind of fun, is that we did a study, I think it was 90 days, it might have been 6 months, many years ago, for a device that was meant to treat or deal with women who had recently had children. They have a lot of repercussions of having a child that's, 8 pounds something coming through their hips, the sciatica and the various other maladies that may form. And a customer was interested in looking at that, and they had all these things they wanted to measure, which we did. However, it was also found through the testing processes that there was a consistent finding that we weren't looking for that was really intriguing. And that was that the people under test kept telling us that their husband, their significant other, or other people were saying, I'm not trying to be sexist or anything, it's just communicating a test finding, is that these people said that they were getting comments that their butts looked trim or fit. And at first you say, this is crazy. But when you look at the device of what it was doing, while they were passive in the device, it is stimulating a certain part of the body to try and correct these maladies of pregnancy. And as unexpected benefit is that it was increasing tone substantially, or at least observably, by untrained people or people very familiar with their partner's anatomy and so forth. So where they're commenting about it, they're not being asked about it, they're just commenting of their own volition. So that's clearly something else. But if you can say, my device makes your back end more tone without you doing anything than sitting at 10 minutes a day, there's a marketing proposition in that. And that was a documented finding of which there was very good data. So the something else sometimes is not as promising or as helpful, but sometimes it creates a really good other thing, or sometimes it says, what we need to do is we need to test something different and a little differently, because maybe it isn't really good at cleaning grease off aluminum if you don't let it set on there for 30 seconds first before cleaning it. So there's a set dwell time we need to do. New protocol. Everything the way it was, add 30-second dwell time. They all get the same thing. Directed use, as directed on all these other Ajax, Comet, they all get the directed use. But my product now gets a 30-second dwell time. It's my directed use. Test it again, and lo and behold, wow, look at that. Now we really can claim that for QVC or show that to Costco, or wherever it may be. So that's the something else. And as the slide shows, it can lead to other important and useful development of the data or refinements of the protocols. Not that you're cheating or anything, just now my product, we've learned, will do better another way. And then that should be the basis of our comparison. With that, hopefully I've furthered your understanding of comparative claims and claims in general and comparisons and kind of strategies and thoughts about how to approach them. And hopefully it will be useful. I'm sure for some of you it was not new ground in some cases, but hopefully it was still new ground in other cases. We do a lot of that work here. We've been doing it for a long time. I think we've seen a lot of stuff, and hopefully that came through to you, the listener, and we're appreciative here at Contract Laboratory for you taking the time to hear us out. Now, hopefully we've anticipated some of your questions, and let's just see if we can't answer anything that may be lagging or nagging in your thoughts with the Q&A we prepared for you.
Okay. Thank you very much, Richard. At this time, we are going to move into our question and answer session.
Well, we have prepared a number of questions that are likely to occur to somebody who's watched this presentation and contemplating this type of work in their facility. So we'll hopefully catch the thoughts that you have, give you some response and some things to think about in respect to them. So if you would, please.
Thank you. Okay, let's start with the first question. Can standards still be used in some way for comparison or claim testing?
This is kind of a hybrid model where the client will like to have standards be the basis of their findings and their data, and the lab will want to have that. However, as we've discussed in the presentation, specificity of the standards don't allow you to follow one through. However, there's often times where there's procedures within a standard. Maybe the standard is based on a different product, but it's a very useful procedure, such as a gravimetric weighing procedure, where basic weight determinations for example, how much drying or how much saturation something may have had is going to be determined. Following that procedure, ASTM, whatever it may be, or something similar, would give additional robustness and professionalism to the data, comfort to the client, and also on a challenge, if there were to be one, some backing that you're using best practices, which is from the presentation we've discussed, kind of the key to doing something that isn't purely standards driven, but following best practices and good science, robust science. Next one, please.
Great, thank you. Okay, what are key considerations when designing comparative tests that may become the basis for claims?
The first thing to think about is how is the claim ultimately going to be used? And the answer to that typically comes back to, while the client may or may not think of it this way or state it this way, but oftentimes it's going to end up as some form of a comparison that will be published or represented to others. That being the case, there may be a challenge to that, meaning somebody said that's not right. So what we want to do is we want to make sure that when we prepare a protocol that we're taking usage cases that are not, for example, slanting the playing field purely for your customer, the client, but instead is a usage case that might be considered typical, because should it be challenged, if it's being used as the end user would use it, and it's in the test protocol, and that's upon which you're taking the data, there's a much lower chance that it's going to be considered not representative, invalid, not robust, or in otherwise or in other ways defective. So the quick of it is you want to make sure you use a typical usage case and maybe a few of them, because that would be your best offense and defense at the same time. Next one, please.
Okay, thank you. How should samples to be compared be provided to the lab? And relatedly, is chain of custody an issue with tested samples?
Kind of an extension of the last question. I think it's prudent to assume that there's going to be a usage for this data that may, over time, that may be scrutinized. And as such, you would want to make the data as robust as possible. And that starts with the samples themselves. Where did they come from? Do we know they're tainted or not? For example, if the client supplied them to them, is that something they've had on the shelf for 6 years and not shipping anymore? As an example. So one of the things that we try and do here is that we like to have the products fulfilled direct ship from, say, an Amazon or a Walmart to us. The client can arrange the sample to be sent to us, and we prefer that they do. That way we know they've selected the sample that they want. We confirm when we get the sample, this is the sample that should be tested, this is the right test article. But also we know that if it came out of Amazon, if it came out of Walmart, this is a current product. This is the current iteration. If the logistics of these systems are so robust that it's probably not been on the shelves very long at all. So what I am testing is representative. And this should be for any competitive sample. Now, the client may be supplying something else direct from wherever they have it, their test lab, whatever it may be, which is all well and good, and that's understood. But for the other items that will be tested, you want to make sure there is a chain of custody and a representative nature to the sample upon which that data has been generated. Next question, please.
Perfect. When published standards are not the testing basis, what does the testing deliverable then contain?
Of course, there's stylistic and procedural things to consider based on your own facility. However, being that they can't refer to, for example, an ASTM number and somebody purchase that standard and see exactly what process was used to create the data, you need to disclose the recipe upon which the data was created. So the deliverable needs to have obviously the protocols that were followed, as well as best as possible, the foundation for each of those protocols. And what I mean by that, for example, adenosine triphosphate, ATP, may be used with for example, in a sanitization type assay, where somebody is swabbing something, putting in an illuminometer, getting a relative light unit reading. Well, it would be helpful to show what the resolution of the instrument is, that there's any calibration on the instrument. For example, showing that the direction of use is, for example, swabbing a 4x4 square, and that you would say per directions from System Sure, we swabbed a 4x4 square, etc. And what we're trying to do is create the recipe so that it can be reproduced in a competitive lab, for example, hired by a competitor who's not real happy with what somebody is saying with their test data. So it's not going to be treated with, you get the lien. If there's a question, it has to be the data that they generate should be consistent with the data that was produced for your customer. And all these levels of detail help make sure that the investigator that is not your lab can come up with a relatively similar result such that you can say, yes, it's not the same, but it's very similar, which is about as all you can ever hope for. You'll never get the exact same result. So the other thing I would add to that is that, at least from our perspective, a picture tells 1,000 words. You try and describe in great detail many things, and you try and be specific, but good illustrations are also very helpful, because if it ever comes down to what about, you may end up relying more on your image catalog than you originally anticipated, but it oftentimes will make an important difference in helping clear up any matter that may be at issue. The next one, please.
Thank you. When testing is not based on standards, doesn't the lab then assume a lot of responsibility and liability for the non-standard testing?
Inherently, they do. And this is something to be very careful about. I'm going to talk a little tangentially about safety because it relates well here. If somebody contacts the lab and says, I want to test to see if my product's safe, well, that's like a booby trap, because who are you? And what happens if something unanticipated happens and there's a casualty or great property loss? Who knows? You said it was safe. Well, I don't know what kind of paperwork you have with your client, but I bet you it can be pierced by a good lawyer. Meaning you've opened yourself up by saying something is safe, that you've made a rendering based on whatever criteria you wanted. And now you are, in effect, a potential pocket when they're looking for deep pockets. So normally in safety, what people will do is they'll say, well, I'm not saying it is or isn't safe. It does comply with UL, name the standard, or TL, which is then saying, I haven't made the determination of safety. I have created data that said it's compliant with the standard about safety. There's a difference. And the reason I'm using this as an analogy, the difference is I did not say it's safe. I said it's compliant with the standard. And it's the same way with the lab, is that you can't say, I'm going to give you claim substantiation, because, again, a great lawyer will find holes in everything. And as a result, what you can say is that you're going to generate data that is designed to investigate the claim or the nature of the claim. And from there, we suggest counsel, inside or outside, advise you what to do with that data from there. And we also put in place language that we put into an email or into a deliverable saying it's purely for discussion. We're not saying use the claim for this or for that. We're saying, based on what you're telling us, what your goals are, this is what we as testing professionals are going to conduct in pursuit of a demonstration of whether or not that seems to be the case. So in my communications, or in the lab's communications, and in their contracting, there's a disclaimer saying we are not doing claim testing to prove X. What we're doing is we are designed testing to create data that may or may not support the claim you're chasing, and that professionals that deal with language of copy in publications and other related legal endeavors like broadcast TV and stuff, they should make the determination about what does this data support, what is acceptable. And I'll give you one last example. I know it's the long way home and it's a long-winded answer, but I think it will be helpful. We have one very large customer who does a lot of TV, direct TV and other similar type marketing. And their head of their in-house counsel says, I don't care, just so long as I don't get embarrassed. That's my only standard. We have another customer in the computing space, Fortune 50, where if they don't have every serial number from inside the the packed battery housing that can prove it's the correct one and everything else, they're not making any claim. It's got to be 100% checked out every way, and it goes through layers and layers at the even after the council's looked at before it becomes part of a claim. So there's great differential in how somebody may or may not vet the data, but that's their burden, not the lab's burden. If you get in between that, you're putting your facility in harm's way, and you'll end up, if nothing else, getting into some legal maneuver to extract the lab, which is going to be probably more than the profit you ever made from that exercise, that project, or those projects. Next question, please.
Fantastic. Thank you. So this will be the last question.
Mm-hmm.
What if the potential customer is trying to orchestrate a test that the lab does not consider adequate, advisable, or has reservations about?
I hope everybody watching this video is smiling, because who hasn't had this customer? Budget gets in the way, time gets in the way. Oh, you just need to do something simple, and then it turns out to be a big blown out lawsuit that they're involved with, et cetera, et cetera. So there's a few ways to look at it. One is, I guess, the way I prefer, which is saying, what would be the minimum that in the most aggressive stance you can consider prudent, and tell them that's the minimum and here are the risks with it. And then, of course, present at the same time the preferred embodiment as well as something in between, and help them understand what the difference is of the deliverable, the robustness of the data, the quality of the data, the predictability of the data, all these things. But there are times where the customer just says, no, I want the foolish process. And they don't call it that, but we may consider it. And depending what happens is that sometimes you can say, well, if you're just doing like a quick range finding, that's okay. But they need to know that's all the utility of this data would be. We're just kind of getting a quick feel for which way the data is leaning, and it may or may not be particularly representative. And if they understand it as such, and you believe that really is taken as such, and and I would also say it's represented in the contractual matter that you contract this project upon, that would be acceptable. But a lot of times it starts out with good communication about what is the limitations of the good, better, and best. What are the likely uses of the good, better, and best? And I'll leave with an example, which is the sample of one. When we have the sample of one, is that representative or is that the outlier? You tell me. We won't know. The thing fails right when we're starting to work with it. Do they all fail, or was this just a bad one? If I get a really crazy number, I have nothing to check and say, is that crazy number really right? I can't even look at another one. These are all the risks, and they need to know this. A lot of times when you do a good job at communicating that, they'll come closer to the suggested or prudent protocol. And it's a matter of communication with a lot of layman references, because in our industry, as I think any listener in this webinar is likely to know, testing is not something a lot of people deal with regularly. It's kind of a extracurricular activity for somebody, or it's something that they're not primary duty. So don't assume a lot of sophistication on the other end of the phone or in a meeting. And you have to start with a more rudimentary basis, and that will serve you well. And I think that should cover our questions.
Fantastic. Thank you, Richard. So this brings us to the end of this webinar. Just a reminder that this webinar will be available on demand shortly following this live presentation. Please watch your email for a message from Contract Laboratory once this video is available. On behalf of Contract Laboratory, I'd like to thank Richard Slavenko for all the hard work he put into his presentation. And I'd like to thank all of you for taking time out of your busy schedules to join us. For more information on all our upcoming or on-demand webinars, or to learn more about outsourcing your laboratory testing and scientific projects, please visit our website at contractlaboratory.com. We hope you can join us again. Thank you and have a great day.